The famous space race involved the US and Russia and brought out the best in the two nations. However, the US is in another space race, and this time it is against Asian giant China. What makes the race interesting this time is the inclusion of a private company, SpaceX. China is going against the US and SpaceX by building a new 800-meter rocket to explore space. What is this new bizarre rocket China is building, and will it help China overtake the US and SpaceX? Join us as we bring you everything China has revealed about its new 800-meter tall rocket to beat SpaceX and the US. When you speak of space exploration, many old-timers will remember the bygone days of the US and Russia competing for who would do what first. However, those days of competition are gone, and we now live in a world where the US and Russia cooperate in space matters. For example, the two nations both run the International Space Station, while Russia was launching US astronauts to the space station for a fee. The US has also purchased rocket engines from Russia numerous times. However, the space race has welcomed new entrants, including governments and private companies. One of the most successful private companies is SpaceX, founded by the world's richest man, Elon Musk. In so short a space of time, the company has overtaken all other players and become the mainstay of the American space industry. It currently operates two rockets developed in-house, the Falcon 9 and Falcon Heavy, which it uses to launch payloads to orbit regularly. SpaceX's clients include NASA, which has been using SpaceX's Crew Dragon capsules to move cargo and crew to the ISS. SpaceX also launches missions for other private companies, including satellites. Other prestigious SpaceX clients include the US military. SpaceX is forging ahead with its new rocket, the Starship, so powerful and tall that nothing like it has ever been built. Musk plans to colonize Mars, and the Starship is the vehicle that will help him do so. Also among the entrants to the space race is China, the Asian powerhouse. This country has also enjoyed a rapid rise and is now competing for the top spot. From 2016 to 2021, China launched a total of 207 space missions, an imposing tally, but it is getting even more ambitious. China launched Tianhe, the core module of its new space station, in April 2021 and sent two 3-astronaut missions to the orbiting lab shortly after that, one in June and the other in October. The country plans to finish building the station by launching two other modules known as Mengtian and Wentian. In addition, China is building a space telescope called Zhontian, which will launch to the same orbit as the space station and dock with it periodically. Zhontian will launch within the next 5 years, the new document states, and the space station will get quite a workout during that stretch. Astronauts will live there on long-term assignments, conducting various research and maintenance activities. China also aims to put boots on the moon in the near future, a bold goal getting serious attention over the next 5 years. Over the next half-decade, China will continue studies and research on the plan for a human lunar landing, develop new-generation crewed spacecraft, and research key technologies to lay a foundation for exploring and developing cislunar space. In January 2019, China's robotic Chang'e 4 mission became the first ever to pull off a soft landing on the moon's far side. In December 2020, Chang'e 5 brought pristine lunar samples back to the Earth, the first time that had been done since the 1970s. And in February 2021, China's first fully homegrown interplanetary mission, Tianwen-1, slipped into orbit around Mars. In May of that year, a rover called Zhurong separated from the Tianwen-1 orbiter and landed successfully on the Red Planet. Meanwhile, planet Mars has a Chinese rover actively exploring. Videos have shown the vehicle trundling over the rocky surface of the Red Planet. Since landing in May last year, the Zhurong probe has been busy seeking clues as to whether Mars once supported life. Mind you, there is no answer yet, but the rover has so far traveled over 410 meters. After the US, China is only the second country to land and operate a rover on the Red Planet. China is not slowing down yet and is now talking about putting in space an insane spacecraft that will be at least 10 times the length of the ISS, which is currently the largest spacecraft flying in space. The International Space Station is about 357 feet long and 246 feet wide, or 109 meters long and 75 meters wide. This is just about the size of an American football field and took 10 years and more than 30 missions to assemble, involving the efforts of 5 different space agencies representing 15 countries. It cost about $100 billion to construct and costs about $4 billion a year to operate. Meanwhile, China is banned from participating in the International Space Station by an act of Congress restricting NASA's cooperation with Beijing. Congress banned NASA from using government funds to engage in direct bilateral cooperation with either the Chinese government or any organizations affiliated with the Chinese government. But China is not new to building megastructures, so it is not surprising that it wants to build big. The Great Wall of China is an early example of a megastructure. What is amazing is that China wants to put such a colossal structure in space. The project of assembly mechanics of the mega-sized spacecraft is among the first batch of major projects to be studied in the following 5 years, according to the project outline recently published by the National Natural Science Foundation of China. Experts believe the spacecraft could have broad applications, such as building a space power plant that will generate electricity for the planet. This equipment could include enormous crewed spacecraft, orbital telescopes, and even space-based power plants composed of modular components that would form megastructures once in orbit. But why is China building this humongous spacecraft? Researchers at the Chinese Academy of Sciences have warned that the rapid development of space technology and the increasing demand for space missions means that the traditional spacecraft manufacturing, deployment, and launch methods have been unable to meet existing needs. Zihui Zhu, a roboticist at the CAS Shenyang Institute of Automation, explained that in-space assembly technologies could effectively adapt to the assembly of large space structures, improve spacecraft performance, and reduce operating costs. The Chinese government is inviting scientists to conduct research into new lightweight design methods that could limit the amount of construction material that has to be lofted into orbit and new techniques for safely assembling such massive structures in space. By far the biggest challenge would be the price tag due to the huge cost of launching objects and materials into space. The ISS cost about $100 billion, as noted earlier. Building something 10 times larger would strain even the most generous national space budget. However, much of the costs depend on what kind of structure China will eventually build. For example, the ISS is packed with equipment designed to accommodate humans, significantly increasing its mass. But if we're talking about something that is simply long but not heavy, then that changes the calculation. Building techniques could also reduce the cost of getting a behemoth spaceship into space. The conventional approach would be to build components on Earth and then assemble them like Legos in orbit, said Peck. But 3D printing technology could potentially turn compact raw materials into structural components of much larger dimensions in space. And there is a more attractive innovation: sourcing raw materials from the moon. Low gravity compared with Earth means launching materials from the moon's surface into space would be much easier. Still, that first requires launch infrastructure on the moon and is therefore not an option in the short term. There are other issues that the massive spacecraft developers will have to solve. When a spacecraft is subjected to forces, whether from maneuvering in orbit or docking with another vehicle, the motion imparts energy to the spaceship's structure that causes it to vibrate and bend, Peck explained. With such a large structure, these vibrations will take a long time to subside, so the spacecraft will likely require shock absorbers or active control to counteract those vibrations. Designers will also have to make careful trade-offs when deciding the spacecraft's altitude. At lower altitudes, drag from the outer atmosphere slows vehicles down, requiring them to constantly boost themselves back into a stable orbit. This is already an issue for the ISS, but for a much larger structure, which has more drag acting on it and would require more fuel to boost back into place, it would be a major concern. On the flip side, launching to higher altitudes is much more expensive, and radiation levels increase quickly the further from Earth's atmosphere an object gets, which will be a problem if the spacecraft houses humans. One good purpose of China's new mega spacecraft would be as a space telescope. A space telescope of that scale could potentially see features on the surface of exoplanets in other solar systems. Let's hear what you think of China's new mega spacecraft in the comments section below.